Thursday or Friday, most likely Friday since I'm going to Tuesday and Wednesday. So keep that in mind. This section is going to talk about just some more uses. So the thing that you guys struggled with a little bit on that last homework were the word problems. And that's what this is doing. It's just giving us more practice reading a problem, drawing a picture. The math is the same as what we've already been doing, setting up our trig functions. There's nothing new there. The difference is you're going to have to be able to draw your own picture to match the problem. The one new thing in here is bearing. And this is actually something that is used a lot. This is one of those places where trig is used not just in my classroom, but if you're talking about bearing, that's a big thing in navigation. So it does come up. When we're talking about bearing, it is an acute angle, so between 0 and 90, formed by the north-south line and line up. Okay, so here's the difference. We've done reference angles, always go from the x-axis. Bearing is measured from a north-south line. So anytime I tell you about the bearing, you have to have a north-south line to look at. When we are looking at bearing, it can be written one of two ways. It would either have an N or S. What do you think those stand for? North and south, followed by a degree measurement, and then E or W for east and west. So it would be like N 27 degrees W, north 27 degrees west. Or it might just be a single degree measurement, and in that case it is measured clockwise from due north. Okay, so the two options, I might give you a bearing that has the north and south, east and west in it, or I might just give you a degree measurement, which could be any degree, but it's measured from the north-south line. So the first thing we're going to do is just look at some problems and write down the bearing that goes with each of these. When we talk about bearing, it is from one point to another. So this is bearing of B from point A. So if I'm talking about this bearing, I am starting from point A. So I'm at A. So if I wanted to use the first notation, to get from A, would I go north or south? North. Okay, from this north-south line, how many degrees is it? 40 degrees east or west? East. Okay, so that's my north, 40 degrees east. All right, if I wanted a single degree measurement, the other notation is just the number of degrees from due north going which direction? Clockwise. Which way is clockwise? Okay. So spinning this way, how many degrees is it? Just 40 degrees. So those would be the two ways I could write that bearing. Make sure you're filling this in on your handout, please. On B, starting from A, how do you get to point B? North, 65 degrees, which direction? West. Or, the second notation is, from due north, how many degrees would you have to spin clockwise to get there? 295. We know all the way around is 360, so 360 minus 65 is 295 degrees. Okay, C. If I am looking at this one, from A to B, which direction am I going? South. Okay. How many degrees from the north-south line? 70 degrees east or west? East. Or, from due north, how many degrees does this thing spin? Okay. From here to here would be 180 minus 70. We'll give me 110. D, what would this bearing be? South, 20 degrees west. or from due north 200 degrees. Are there any questions about how we did that bearing? Do I have time to do an example and this quiz? The quiz shouldn't take very long. If you know your stuff, it should be fast.
What if you don't?
Well, you should. I understand. I don't want to. Okay. I really want to do this. Okay, let's pause. Let's take this quiz. Radar stations A and B are on an east-west line. So what do you think we should do? We're going to draw a picture as we go. We have A and B, east-west line. That means we have a horizontal line. Station A detects a plane at point C on a bearing of 53 degrees. Anytime you see bearing, we are going to measure bearing, we have to have a north-south line. I am measuring my bearing from station A. So what I need to do is draw a north-south line at A. Lightly draw that in. Okay, I'd like to do dashed lines for those. I'm just drawing my north-south line there. So from point A, the bearing is 53 degrees. That means, since I didn't say north-south, it means from due north we went 53 degrees clockwise. So from here to here, we are talking about 53 degrees. At the same time, station B detects a plane on a bearing of 323 degrees. So now, what do I need at point B? A north-south line. So at B, from due north to get to this thing, it spins a total of, so this angle is 323 degrees. What else? There's one piece of information that I did not write down when I read this. What was it? Yeah. A and B are 8.6 kilometers apart. And we are trying to find the distance from B to C. So I'm looking for this side. If I have a right triangle, I can use trig functions. But I have to know that it's a right angle. Or I have to know that I have a right angle to do that. So we need to find some angles inside my triangle. Okay? If you have a north-south and an east-west line, what angle do they form? 90. So if this is 53, what's this right here? 37. 90 minus 53. Okay. This angle, from due north to here, would be how much? 270, right? So, how would I find this little angle in my triangle? 323 minus 270, what does that give me? 53 degrees. So this angle in my triangle is 53. What's 53 plus 37? 90. So the third angle in my triangle is 90. Good news, we have a right angle. So now we can do a trig function. Okay. I want this side, so pick an angle to view from. Let's say I went for my 37. This is opposite. This is hypotenuse. So what trig function would I do? Sine. So the sine of 37 degrees equals x over 8.6. So if we multiply that over, make sure we are in degree mode, and we will get our answer. It's like 5.2. All right. I have excellent time management, guys. Have a great weekend.